Hello, and we're on to the fifth video now in the probability series, and we're looking at and or events. So this will enable us to work out probabilities of combinations of events. Okay, so let's go back to our fair and biased dice. Now, what's the probability of getting a 3? And we've seen this a couple of times already. Well, the number of ways of getting a 3 we know is 1, the total number of outcomes is 6. Probability of getting a 3 we know is 1/6. Okay, let's have something new then, shall we? What's the probability of getting an even number? Alright, even number, so that could be 2, 4 or 6. Number of ways of getting an even number is 3 of them. Total number of possible outcomes, 6. So what's the probability of getting an even number? 3/6. Okay, we could cancel that to a half, but we don't have to. Alright, let's try another one. Calculate the probability of getting a 3 or an even number. So we got that word or, 3 or an even number. So what could that be? That could be 2, 3, 4 or 6. So the number of ways of getting a 3 or an even number is 4. Total number of possible outcomes is 6. So the probability of getting an even number or a 3 is 4/6. We could cancel it down to 2/3, but we don't have to, and in some ways it doesn't help us. So what have we found out? Well, we found the probability of an even number or a 3 was 4/6, even number 3/6, and 3/1/6. Do you notice anything? Look, 4/6 is equal to 3/6 plus 1/6. Or we could say the probability of an even number or a 3 is equal to the probability of an even number plus the probability of a 3. And notice that or equates to a plus. So or equates to a plus. And we could write it in a kind of mathsy way there. The probability of A or B is the probability of A plus the probability of B. Now this only works if the events are mutually exclusive. Now what does that mean? Well, mutually exclusive means can't happen at the same time. So for instance, a football team can't win and lose the same game. Winning and losing the game are mutually exclusive. They can't both happen at the same time. Good. So we can write this then: for mutually exclusive events, the probability of A or B is equal to the probability of A plus the probability of B. We use this quite a lot. Okay, let's have a look at another one of rolling the dice. So what's the probability of getting a 3 on the first roll and an even number on the second? Alright, so well, to help us here, we're going to do a little bit of a table. There's the first roll there. We can have 1, 2, 3, 4, 5, 6. Second roll, 1, 2, 3, 4, 5, 6. Oh, we've got a little X then to show what could happen, each possible outcome. Oh, there we go, pretty pattern. So let's have a look. The total number of possible outcomes, well, if you count up all those X's, there'll be 36. Now, how many ways are there of getting 3 first and then an even number? Oh, let's have a look. We'll put a green circle around them. And there's 3 of them. So we can say the probability of getting a 3 and an even number is 3/36. Okay, so what have we found out? Well, we found that the probability of getting an even number and a 3 was 3/36. We did this one before, didn't we? The probability of an even number is 3/6, and the probability of getting a 3 is 1/6. Now, do you notice anything? Oh, look, 3/36 is the same as 3/6 times 1/6. Remember, when you multiply fractions, top times top, bottom times bottom. So we could say that the probability of getting an even number and a 3 is the same number as the probability of getting an even number multiplied by the probability of getting a 3. So and in probability equates to multiply, and times or multiply, and equates to times or multiply. Remember that. And now we'll write that in a mathematical kind of way. The probability of A and B is the probability of A times the probability of B. But for that to hold true, the events must be independent. So that means they don't affect each other. So if you roll a dice and toss a coin, the two events have no effect on each other at all. So they are independent events. So we can say for independent events, probability of A and B is the probability of A times the probability of B. And that's it really. What have we found out? Let's just go over it one more time. Mutually exclusive events, probability of A or B is probability of A plus the probability of B. Or is plus. And for independent events, probability of A and B is equal to the probability of A times the probability of B. So or is plus and is times. Or is plus and is times. Remember that and you won't go far wrong, particularly on the next exercise. Have a go with that. I'll speak to you on the next video. Thanks a lot. Bye for now.